we now want to look at scalar multiplication, right? Scalar multiplication in vectors, right? And I want you to write the following note. If a vector AB is multiplied by a scalar k, I'll repeat once again. If vector AB is multiplied by the scalar k, where k is any number, underline the word where k is any number, the result is a vector k times as big as AB. The result is a vector k times as big as AB, sorry. Alright, what are we trying to say? You know, the scalar maps, a scalar is any number, whether it's a fraction, whether it's a whole number. A scalar is any number. And so suppose we have a vector AB, and this vector AB, you multiply by a scalar k, right? Then it becomes KAB. What it implies is that this resultant vector k times is bigger than AB. Are we together? And also parallel to AB. We're also going to talk about concept of parallel lines in vectors, right? And concept of scalar multiplication is very, very easy because, right, matrices, you know that if you are to multiply a matrix by a scalar, the scalar multiplies each and every individual number in that particular matrix, right? Let's take, for instance, we've got vector AB as 3, 6. And then vector AB 3, 6 is being multiplied by a scalar 5, right? It becomes 5AB and then. So, yeah, we have 5 multiplied by 3, 6. This is 5AB and scalar 5e, times are each and every individual element in this matrix, meaning to say, this is going to be 5 multiplied by 3, you get 15, and then 5 multiplied by 6, you get 30. Are we together? That's the resultant answer. That's how to deal with scalar multiplication. I am not going to waste much time talking about scalar multiplication. Okay, let's just give you an example whereby we have vector AB as being equal to, let's have a number here from the book, maybe let's say 4, 1. And then the question goes like, what is minus half AB? Meaning to say this vector AB is going to be multiplied by the scalar, which is negative half. This just becomes negative half at multiplier 4, 1. Are we together? And then we now say negative half multiplied by 4, we get negative 2. And then negative half being multiplied by 1, negative half. So our answer then becomes negative 2, negative half, and this is a done deal. I hope, and I hope we are working together in one accord. I want you to write the following general statement, right? Rekut. The effect of scalars can be summarized as follows, right? The effect of scalars can be summarized as follows. If A is equal to KB, and then if A is equal to KB, then A is K times as big as B. A is K times as big as B and parallel to it. A is K times as big as B and parallel to it. And what's apa zvurungo kuda pachena zvega izvani kuti tine vector rinonzi A ende rakaenzana nevector rinonzi K rinonzi B kana ratimes 1 K. zvazvongoreva ndezvekuti uyu A uyu kauyu akakura K times kudarika B. That's according to this equation. Are we together? Right? A wakakura K times kudarika B. And in a statement yaunofana kugara uchingorangarira nguva dzese ndeyekuti ukaona relationship yakadai kumavectors wobva waziva iwe kuti right mavector akadai aya ari parallel, and anonzi maparallel lines. These are lines that will never meet. Ladies and gentlemen, that's in as far as scalar multiplication in vectors is concerned. Let's move on to yet another very simple concept known as addition and subtraction of vectors. And then, alright. Without munyore statement rinoteera. Vectors may be added or subtracted. It's possible to add or subtract my vectors. And then, alright. Kuma matrices, right? Procedure yeku add ma matrices. Unongotora ma corresponding elements who are added together. Are we together? And ku vector notation, ma vector anonyorwa as ma column matrices. And so suppose we have vector P irinoi minus 3, 4, and then we have vector Q irinoi 0, 5, minus 2. And then we've got a question. Part A of the question asks what is P plus Q, and then part B of the question asks what is P minus Q. How do we go about it? This is what we do, right? P plus Q, motora P in the minus 3, 4, and being added to Q in the 5 minus 2, and 8. So it's just a matter of simple addition here. You are just adding the corresponding elements together. Minus 3 plus 5, you get positive 2. By the way, at this panel, these are my directed numbers. Right? 4 minus 2, 4 plus minus 2, you get positive 2. So our answer here, add P plus Q, the 2, 2. So you don't even need a rocket scientist, you don't need an astrophysicist or a molecular biologist to teach you how to add or subtract vectors. This is just a simple issue. It's like primary school. And then let's look at this one, which is asking P minus Q. Again, what we do on the addition aspect is the same that we do on the subtraction aspect. On the subtraction aspect, vector P minus Q is going to be equivalent to minus 3, 4 on the minus and Q and 5 minus 2. And now, we are now subtracting the individual elements together. Minus 3 minus 5, we get minus 8. 4 minus 2, we get positive 6. So our answer here after after subtracting these vectors, that's the answer that we get. And are we together, folks? This is what we do in terms of addition and subtraction of vectors. Nothing very peculiar on that concept. That is that. So the body concerning that aspect here, addition and subtraction. Yeah, my vectors are there. Right, then Panapa, before we move to the concept here, position vector, right, there is an example that is in the New General Maths book 4, per page 150, and if you have that book, I want you to go to that page, and I will try to put the diagrammatic representation of that question on the board over there, and then we try to solve my questions. This is a typical examination question, so I need you to pay extra attention on this concept. Right. Diagram rakadai shopanapa. We have the Cartesian plan. And then rakadai. I'll just try to leave some space for working, right? That's a Cartesian plane. And then we have a polygon. Yakadai so. Chinoenda chakadai chonogonyera uku. Chagonyera uku chobva chauya apo. Chozouya neapo. Chofanozonangana nechimwe chacho ichanere. Right. So, pana apo pana E. Here we've got D. Here we've got C. And here we've got B. And the coordinates are as follows. And along the x-axis, pana E, tina point 1. So this is A as well. So A na E along the horizontal axis, pana 1. And then A, wakanangana na 2. E, wakanangana na 4. And then D over this side, akanangana na 6. And then B on the horizontal axis, akanangana na 4. On the vertical axis, akanangana na 1. And then C wakanangana na 6 kunoku. And on the horizontal axis, akanangana na 2. And then D on the horizontal axis, wakanangana na 5. This is the question, right? This is just the simple diagrammatic illustration. I'm sorry for these dotted lines. They are just there to indicate where the points lie on the Cartesian plane. As you can see, this is not a graph paper. All right, let's proceed to continue. We can always improvise and express each vector in the form AB. And then form ilunzi AB varongota kuti expressa ma vector ose ari pa diagram here as column matrices. Are we together? All right. The question is ma vectors acho arikuda kumboexpresswa ndeapi? Ma vectors arikuda kuexpresswa ndeapi? Vector AB, vector BC, vector CD, and vector DE. Are we together, right? So the question now is, vector AB ndiani? Folks, like what I told you earlier on, patati introduce some vectors on the Cartesian plane tati. Ukaona vector AB rakadaiswa lede. A iri a certain point, B iri a certain point. Kutsvaga vector AB, unotora ma coordinates a B apedzisira kutaurwa minus ma coordinates a atanga kutaurwa. So vector AB in this case is going to be equal to ma coordinates a B in the end, ma coordinates a B in the 4, 1 minus ma coordinates a atanga kutaurwa ndiani 1, 2. And remember, you need to be very, very meticulous, very careful when dealing with such questions, because vazhinji vanopesanisa. Anonyora y coordinate umusoro onyora x coordinate kuzasi, which is very, very wrong. Right? Very wrong. Like trying to handle sulfuric acid without wearing a lab coat. Right? 4 minus 1, you get 3. 1 minus 2, you get negative 1. So our answer here, vector AB, is going to be equal to 3, negative 1. And then, right? Let's look at vector BC. Vector BC, before Christ, I was puzzled in Chinzwan's Pythagoras theorem, yakagadzirwa 250 BC. The guy Pythagoras, akaitanga 250 BC, right? My theorem arunetsa in this 21st century akatanga before Christ. So my challenge andinayo kwamuri ndeyekuti ungatadza here zvinhu zvakatangwa before Christ. Guys, let's be serious, right? BC, my coordinates are C. My coordinates are C ndi 6, 2. 6, 2 minus my coordinates are B ndian 4, 1. Ready? Takuenda subtract 6 minus 4 ndian 2, and then 2 minus 1 we get 1. So our answer here in as far as vector BC is concerned, according to this column matrix form, the answer is going to be 2, 1. Okay, let's proceed. Vector CD is equivalent to, again, my coordinates are D, 5, 6, and make sure you don't papara like a crazy chicken when dealing with these things. You need to be very, very steady. To say my mistakes, I wonder. 5, 6 from my coordinates are D, minus my coordinates are C, right? My coordinates are C Indian, D 6, 2. As you can see, I'm taking my time when you start Sapanap. As experienced as I am, I'm taking my time. Why? Because sometimes mistakes are inevitable. So you need to be very, very careful, right? 5 minus 6 is equal to -1. Then 6 minus 2 is equivalent to 4. Again, I'm not here to teach you how to subtract directed numbers, right? These are elementary concepts, right? You can purchase the DVD on directed numbers if you need some help in as far as that is concerned. Okay, let's proceed to continue. Do we have another vector? Yes, we have another vector, DE. The word DE reminds me of my A-level studies. There were some equations known as first-order differential equations. I used to like those back in the days, right? It's a concept found in additional maths or ordinary level math, advanced level maths. Those are coming soon as well, those DVDs, right? DE, my coordinates are D, my coordinates are E that's 1, 4. 1, 4 minus my coordinates are D, 5, 6. And then you now subtract, now simple subtraction. 1 minus 5, you get -4. Then 4 minus 6, you get -2. So that's our answer here. No my vectors are now. But question, okay, vector AB mudzidzisa antimati ndi 3 minus 1. Ko vector BA indian anonzi vector AB kana pari pana A panapa. Alright, pana A kwenda pana B ndiye 3 minus 1. Ko kana ABA takumove in the opposite direction. Kana takumove in the opposite direction takuti negative. Are we together? Because vector BA are equal to negative AB. Do you get the point? We try litmus test actually, and look at the is really equal, and that is when we say we must try to prove my mega. Vector BA in the negative AB. Okay. So whatever is, so that BA are equal to minus over bracket AB muna 3 minus 1 and so kuti vector iri rinodzira pasi rozotipa minus 3 na positive 1 because minus pana panenge anyutura kapa positive 1 apa minus arova apa di negative 3 and so let's prove to see whether that is true. So vector BA my coordinates are A minus AB. My coordinates are A Indian 1, 2 minus my coordinates are B Indian 4, 1. 1 minus 4 to an minus 3. And then 2 minus 1 to an positive 1. Minus 3, 1 kunogu, minus 3, 1 uku. Sakata prove and mazuwa nanti. Tunzwana teseba. Okay. Kana warasika. Remember our WhatsApp platform is open. You can consult some of these problems on our WhatsApp platform. We are here 24/7 to help you in your studies. And that's our job. That's my calling. That's my job. To help you to pass your exams. I know most students, if you ask them their career ambitions, maybe I can say 0.5% of Zimbabwe wants to be teachers. I don't know why people despise this profession, but for every person to be right, starting from the head of state up to a general messenger, they all pass through teachers, right? So, better start thinking afresh. I want most people who aspire to be teachers, right, just about to educate the nation. Okay, then the next question now, the modulus of vector DE. The modulus of vector DE, again, vector DE racho antawana rudara. Vector DE indian, vector DE in the -4, -2. After we subtract my coordinates are E from my coordinates are D. And so vector D is really -4, -2. The modulus of vector DE, modulus cannot magnitude, Tatichi previously, it's going to be equal to the square root, yeah, -4 squared plus -2 squared. Maybe wakangana. Ndichakodzoka flashback mbichana ndinopedza nguva. Vector xy rikanzi ritsvagirwe magnitude yaro. Unoti square root ya x squared plus y squared. The same applies to this. DE in this case is equal to -4, -2. So hence the modulus is going to be equal to the square root of -4 raised to the power 2 plus -2 raised to the power 2, which translates to -4 squared is going to be +16 plus +4. So to the square root here 16 plus 4, which becomes the square root here 20. And that's our answer. And maybe you check kuti kuma sets, is it in its simplified form? You need to simplify further. The square root of 20 is the same as saying square root here 4 multiplied by square root here 5, which translates to 2 root 5. So our modulus here, taisiya kuset form yaka simplify, it's going to be equal to 2 root 5. Then let's proceed. The next question now is saying that what is BC plus CD hard? This is very, very, very simple. Very simple. You know, at times I become very, very emotional. Of course, we applaud the decision made by the Minister of Education, Honorable Lazarus Dokora, for banning the beating up of students in schools. Yeah, it's a good decision. Very, very good decision. But at times, my emotion and don't buy it again. Because alright, and they told me BC plus CD, and do your next question, BC plus CD, and then